have more refined notion of actions and so on. But still, I think there is some, I mean, if there is some relation.
No, there is no observation, so there is no deduction.
But
That's what will happen if you observe something and then think back what might have been true. So
but there is some something explanation that you can do with the possible precondition, right? So whether this precondition is true, then you can explain, right? If you look at the model.
Abduction phase would come when he actually fails and he tries to diagnose. He's essentially currently trying to generate a plan that is likely to work in as many models as possible. And after that is, in fact, I think that's a question that Chita also had. After he makes this plan, when he's executing it, he can do a lot. I mean, any information that he gets about failure is an opportunity to learn about the model. So it can eventually become more and more complete. And when you're trying to do that, you wind up diagnosing essentially what would be the reason the plan failed, right? So there is a connection, but I think it's not directly related. He's not diagnosing right now. He's generating constructing a device that's most likely to work under a wider variety of initial state specifications, right? And then when it fails, of course,
to do replanning.
No, not just that. I mean, that's also an option for actually learning the real model.
If I have observation.
So, Brown, if you interleave with execution.
Ask him. Don't ask him.
Okay. I mean,
soon it will be my defense.
Right.
So,
because I mean, he didn't mention executions in his presentation.
No, so,
but if you
so in my work, the planning and execution are separate. But in case we can interleave, I think the plan can be a tree with branches based on the observations.
So do you have execution?
No, I don't have.
right. But my question is, if you take execution into account, is there any reasons to find a complete plan other than, I mean, it's better if just finding the next actions to execute and then learn from it and then plan from there.
I guess if the observation are cheap, then that can be done.
Because I mean, if you find the complete plan before you execute it, you may make a lot of mistakes, spend a lot of time finding the last few actions in which it may not be the perfect one depending on how you observe when you execute earlier actions. So it's better if you just finding the next actions and then execute it instead of finding a complete plan.
But in that case, your next action need to be relative to the goal.
Yeah, how would you do goal-directed search? So you would do the planning, but you only execute the next action.
What you just mentioned seems to be the more like you explore in order to learn.
Right.
To learn the models.
no, he's at the point he's making his online search for the online planning, but the same issues come in any normal stochastic planning too. You can make the way you decide whether you want to go online versus generate the full plan and try to execute it is how costly the failure is.
Yeah.
Right? And how costly the failure is versus how much time you have for deliberation.
Yeah,
right?
but I mean, let's think back about the results slide for the probabilistic FF. A lot of time that it failed to find the plan, in which we don't even know if there is a plan or not. There may be a plan, but it's running out of time. So in that case, should we just take the first action that FF was thinking the most probabilistic and to be leading to the plan and execute it instead of waiting for it, I mean, fail and then saying, yeah, we cannot do anything.
Yeah, so that would be online approaches for probabilistic conformant planning.
Yeah.
But I think the model itself is, still, I think you can do both online and offline. He looked at offline version.
Okay.
Other questions?
So you've assumed the Scripps model of actions throughout this. And I'm wondering what would have to happen to this if you were to admit, say, numeric variables into this domain. And now have some of the uncertainty in the domain be about the values of those numeric variables. So you might have, for example, an initial probability distribution over possible values of resource usage, for example. You could, of course, discretize this and propositionalize the whole thing, but that's going to really blow up the space, right? And the other thing is you wouldn't be taking advantage of, you'd be treating them all independently, and there's a lot of, most of them are your combinations are mutually exclusive with each other. So I'm wondering, have you thought about this issue at all? What you could do about this?
First of all, in terms of quality of the plan, I think if you already have a distribution of input variables, then I think it's nicely can be incorporated into in order to define the probability of success for plan. There's the robustness here.
It's clear that you could generalize the robustness notion if you have a meaning.
Yes.
The question is sort of how would you do it computationally in order to find robust plans? Sounds like you haven't thought about this.
No, I haven't.
So,
but one complication I can see is that if it's like filtering problem where so if I try to plan those distributions, then it can quickly becomes complicated with that particular probability, and it will be a challenge to consider that into relaxed plans if relaxed plan is used.
so did Maria Fart's robustness what? Didn't it just focus completely on the numeric variables?
It's on the durations of actions.
Okay, but I mean, so it's duration, not the effects, not the duration. But then she also focused only on validation, I mean just assessing the robustness, not generating a robust plan.
Right.
Right, I mean that's,
Right, the duration case is, as long as you're not worried about concurrency, right, if you're still dealing with sequential plans, then duration can just be a numeric fact.
that's what I was, so that's what I was thinking. So you were the kind of problem you're thinking of are cases where that I would produce between maybe 10 to 90 units or 90 units or something, and with,
I've got some action, and maybe it consumes between 10 and 30 units of some resource, and I'm not
produces,
quite sure. I'm not quite sure how much.
Exactly,
And I want
yeah.
to produce robust plans.
And so I guess over time during the search, you can maintain those set of ranges, those set of constraint, temporal constraint, I guess. And then maybe, I don't know if there's any similar notions with the number of, I want to find a justifying assignment that's actually violate less number of constraints.
So Charles, that is one the work by many years back, the work that you were involved in by Jay, and you had a Ichikai 2005 paper on metric planning, right? Now the point, of course, is so one thing that I don't know if you noticed is that planning graph comes in an interesting way in his work. If you look at the relaxed plan construction, I mean the whole notion of the approximate projection is kind of connected to planning graph. The reason he still gets soundness is he is taking the delete of the certain deletes are being taken into account. It's only the possible deletes that are being ignored. Because of which, so basically the approximate projection is very much like what planning graph does, but except that it completely ignores deletes. And the reason I'm bringing this up is the work that Jay and you guys did, I think you were involved in that. that is basically numeric planning, and where the heuristic computation takes the intervals into account.
Yeah.
And I think
Something.
I look at this work and I'm thinking basically these ideas are connected. So some of the, if you wind up handling it at the heuristic level, you know, that
Right.
still can be helpful in
Yeah, but in this particular case, there's still a lot of complications because all the action instance of the same one will have the same, it's still like incompleteness versus stochastic, right? So
yeah, I don't know that.
and I don't know how we can take advantage of that kind of information.
That's not as, all I'm saying is when you had exact numeric effects
Yeah.
during the heuristic computation, you went ahead and started maintaining intervals anyway.
Okay.
Now you actually, the base model itself will have interval effects.
Right.
So the funny thing is the planning graph is the only place where you would think of propositional lists in deterministic planning. In his case, even the approximate projection already becomes propositional lists instead of being sets of states.
Right, but
So-
I think that's the difference between, I mean, you have two type interval, right? You have stochastic numerical effect in which for each time you execute the action, you can have any of the value between the interval. But in this particular case, you know that there is an interval, but as soon as you execute the action, you know exactly,
yeah, but you.
and the next subsequent one is become. So I just wonder how you
yeah,
can take
I think
advantage of
it's-
that.
Yeah, we should talk, obviously we should talk offline, but I think it's very similar in my view, because I think in one case, it's the uncertainty is because you haven't decided to, in the case of planning graph heuristic case, the uncertainty is because you haven't taken the time to actually consider all possible projections. Whereas in the other case, you are considering all possible,
Yes.
you're still not executing anyway, right?
Yeah, so actually in this particular case, maybe we should go back to online versus offline planning, because online planning in this particular case will give you much more than stochastic online planning. Because as soon as you execute one action, you narrow down the set of
There
events.
is, you should point out the work by E.L. Amir, right? Amir and Engelhardt. So, I mean, you can combine the
Yeah,
planning and execution in that case.
and it's more beneficial than combining planning and execution in stochastic planning.
So your point is online has a bigger advantage in these scenarios
Yeah.
because you can actually learn about the model.
You narrow down
Whereas
the
in
set
the other
more.
cases,
You
you learn
cannot.
nothing. Yeah, that's a fair point. I think. But if once you fail, I mean, the point is when you do online, you actually execute, and if you execute and you fail, that's the end of the world. So I'm not sure that you would like a robust plan for NASA, which involves doing one action and figuring out what happened on Mars.
Right, not for NASA.
So it's the same situation still.
Right.
Yeah, as I mentioned, I now remember EU Amir in AGAPS 2006, the paper with Alan Chang. But he used SAP-based planner. They generate a plan and execute, and when they fail, they observe, and then they revise the models and do that again. But I'm pretty sure they didn't have the possible predictions in their models.
Yeah, so my more general question was, what happens really when you step outside of this single strips propositional model? As soon as you start introducing functions in here, if they're discrete functions, probably okay with this, although you could take more advantage of the fact that the different possible values for the function are mutually exclusive with each other. Right? Whereas if you turn it into propositional, you have a bigger combination in your D space than you need. But when you go to the numerics, then you're going to get this explosion.
Yeah.
So to a normal, I mean, with a normal paper presentation, you will end with the slide on future work, right? So I wrote out something, but I just want to hear from you. Like, I mean, if you spend
Yeah. So
7 more years doing PhD, then what are the topics that you have taught in? Put
I only
something
talk
into.
in the scope of my dissertation for the future.
Right. I mean, for sure, there's things that you
No, so
you
I
have thought about, but you haven't had time to finish, right? So.
yeah. So I in my dissertation I also wrote about a scenario where you have both incomplete user preferences and incomplete domains. And in that case, of course, you need to define what is meant by the, because you have incomplete user preferences, you want to present a set of plans, but you also have for each plan which can fail. And so, what is the quality measure for that plan set? So basically, the probability of success for plan will be used to take that into account for the quality that you have, that the user have when she selects one particular plan. And I also show that the IPF measure can be extended with the robustness measure. In some case, we can choose the one parameter in that functions, that value function, so that the monotonicity property hold, which means that so in multi-objective optimization, one of the property that they want for the set is that if this set is dominate that set in terms of Pareto optimal, then you want your indicator, your functions follow that. So and so there are only 2 measures have that property, monotonic property, which is IPF, and another one is hypervolume. And I show that in some conditions you can have that for the IPF plus robustness.
Okay.
Yeah.
Well, that would be interesting how you can use that one to guide them. Yeah.
So since you're working following the straight model, you're not obligated to consider any disjunctive information here, right? So disjunctive precondition or disjunctive effect. But I just wonder, if you want to relate to that kind of more complex domain, okay, so you know the possible precondition is either A or B, but you're not sure which one is which.
I think with that more complicated action models, I think one generic approach can work, which is SAT-based planning, where you can actually convert the planning problem into SAT, and then any assignment you want to file an assignment, but that to file. I'm not sure how to. So after I convert that problem into SAT, I guess there will be a notion where one assignment can be better than another assignment in terms of what I have here is robustness. But so my point is that given more expressive action models and you want to fit that into these models, then I think SAT-based approach can work.
Yeah, I think that's I mean, disjunctive precondition, you can compile them away by, I mean, the same way you can compile ideal negative precondition into, without negative preconditions into, you can compile away the disjunctive precondition. So I think for that particular case, I think you can convert it back to the formula that is using right now.
So basically generate all possible disjunction as one proposition.
Yeah, I think type like that.
That's also kind of blow up.
Yeah.
Do you have any slides on the other part, like the preference incompleteness part? The preference incompleteness part? Just to give a quick summary. We don't remember when you had the preference proposal, right? tell what you did there or what are the contributions or something like that.
Yes, propose a presentation.
Like just give me a 5-minute overview of the
So in that work, I consider two situations. The first one is where the user preferences are unknown, and in that case, because you do not know anything about the user preferences, so the quality measure must come from the models. Actually, I have this. So when you have unknown preferences, then which also means that you do not have any knowledge about the high-level feature of interest that the user interests. And so the choice of the quality measure must be motivated by the models. And so in this work, we consider, for this case, we consider diversity measure based on syntactic distance between plans. There's no semantics here. And so we consider distance between two plans in terms of set difference with respect to the action set.
No, so what is the user preference here? No preference or?
No preference.
Okay.
The user has preference, but you do not know.
You don't.
Yeah. Yes. And that's why you want to find, let's say, find plan as much different as possible.
Okay.
Yeah. And another case.
So you use the distance measure to find
Yes.
different ones.
Yes. And for the approach, we consider we extend GP CSP, which is a CSP based planner, and LPG to generate the plan set based on that distance measure. Another situation is where we have partially known preferences. Here I particularly consider the case where you have two objectives, which is time of the plan and the cost of the plan. And I assume that the user will compare plans using a cost function, which is a linear combination between these two features. But the weight here is unknown.
What is the time of the plan?
The time means the time to finish that plan and if you plan.
Execution of the plan.
Yes. Yeah. And the cost of the plan. And it's a linear combination of these two features, but the weight is unknown. But we can represent it as distributions.
So the user is giving you
the complete set of
cost function and
feature.
of how to compute the cost of the plan.
The cost of the plan is the summation of the cost of individual actions.
No, so what is the user preference here?
The user preference is specified by this cost function.
So if I'm a user, I want to give my preferences, so I give you my cost function.
Yes.
But the most important thing is that W is not given. You only say that I care about the make span of the plan and the cost of the plan. But how you combine those together into a single number is not given. So, a part of what he basically W is unknown there. If you also provide W, then it's a single objective, known single objective optimization problem.
And so for these situations, I use the IPF measure. In this case, IPC, and then I compute IPF of the given set, and then I consider three approaches to generate plan set. The first one is you just sample k value of W, and then for each of those generate plans. and heuristic take into account the ICP and hybrid combined is the first two approach. Yeah, that's all.
Okay,
For the
that's
first part.
great.
Another question?
All right, so this was a case in which your the preference measures, you actually were considering numerics, like cost.
Yeah, but the cost,
But
yeah, the
that's-
cost of the action cost, yeah.
Action cost.
And in fact,
But that would apply to any other numeric measure as well, like, resource utilization.
so there was a time when one of the, like detours he took that didn't pan out, involved actually, I mean, you should remember all this at the time when you were pricing the defense, but it involved actually trying to convert diverse plan finding as a metric temporal planning problem. So you will compile it into a metric temporal planning problem, which is the kind of thing you're saying. So and that just didn't pan out in terms of, we spent a bunch of time on that. It just didn't work faster than the diverse plan generation. So, but that was, when you do that, then essentially everything is at the same level, so the cost can also be seen as some sort of a, an effect of this compiled action. So, but yeah.
Right, if I was given a planning problem and I didn't know what the user's preference function was, and I was trying to get diverse plans, my first guess would be to actually take all the numeric things in there, right?
And then make them
And
different.
treat that as a multi-attribute
Yeah.
optimization
Yeah.
problem and try to give diverse, one that gave you good cost, another one that gave you, good gas mileage, another one
Yeah.
that gave you.
Yeah.
Yeah.
I still have one more question. So you have the SE and GE models, right? But in all the implementation, you only use the GE and not the SE.
For heuristic, I only use SE.
I thought you use. Okay.
For the compilation, I use GE, but that can be expanded for SE to the compilation. But a little bit challenging with the heuristic approach because the SE gives me a very compact
Right.
set of correctness constraints. That doesn't hold in the GE. So for the GE, one thing we can do is try to do for the correctness constraint, do the state-based encoding, where now you not only have the variables for the possible prediction and effect, you also have state variables. And in that case, specifically the property that I use to have the low bound, upper bound no longer hold.
Okay.
But I guess one can try to use more general approximate model counting approach. But that's correctness constraint is actually big. So actually in probabilistic attack, they set up a set of constraints using state base, and they actually
Right.
call the exact weight model counting.
Right. I remember that.
But the fact that, I mean, this is one of the running conversations that we're having, which is the fact that he cannot get probable upper and lower bounds in the heuristic computation is not a good enough reason to actually, support G semantics. Because I think suppose you went ahead and used wrong approximations anyway, it's all in heuristic. How does it matter what happens in the heuristic? Because eventually you are checking everything at the base level.
Yeah.
But I mean,
Yeah.
he was very insistent on having the property for the heuristic, that,
Right. Right.
But the way I see it, heuristic is
Heuristic
where you
anyway.
can play any random things,
You
because
realize
as long as at the
yeah.
base level you are not giving out,
Yeah.
so I think, I mean,
No, I agree with this.
I mean, even if I do not come up with a better approximation, if I just use these approximations when they are not allowed to be used, it still is not the end of the world in my view.
Right.
Right,
Because when you do the state expansion, you still
exactly,
those,
yeah.
you
So
can check for that. And I think one thing was missing from that slide is you didn't give like real world example in which SE is more appropriate than G. So which So when you divide into two different set of things, right? So what kind of applications do you think G is more appropriate than SE? Or is that a convenient definition of expansions?
I guess it depends on the
Like-
user.
I guess NASA only use SE and not G then.
No, SE nobody uses actually. SE is used by people who write algorithms so that they can provide quick proofs or quick pruning. Okay, because this is where you are saying if one action fails, the entire plan fails, after which there is no hope of trying to improve the plan. So I mean, basically in the SE semantics, if you have two actions supporting the same condition, if one of them is likely to fail, then how many ever actions you add, then that guy fails, it will take down the entire plan.
I thought it's more conservative than GE, right?
Yeah, but I mean, how conservative in the sense? It's like
That's
the
why
moment one thing happens.
So like
It's the same thing. For conformant planning, strip semantics don't make any sense whatsoever. But people use them so that they can do pruning easy. That's all.
Yeah.
So, I mean, you should use the conditional semantics, you know. And those are more general anyway. So if you want to say there's some preconditions actually cause, lack of certain preconditions cause failure, you can always model. I mean, GE can model SE, close to, but SE cannot.
We ended up actually going into a more complicated semantics than GE, one in which the executive was smart enough to take a look at the state it got back, the current state it was in, and decide whether or not, based on the causal structure of the plan it was given, whether or not that plan was going to fail, or whether it could continue with additional actions in that plan and still achieve the goal, without actually going back to the planner. And that semantics improved the outcome of the plans, but it was damn hard to analyze and put it into the heuristic in the planner.
So I still didn't get it. So that's the reasoning within the executive model
Yeah,
engine, right?
Yeah, right.
But
The
it's-
smarter you make the executive, the harder it is to come up with the right heuristic for the planner.
Yeah.
But in this case, you wouldn't even go back to the planner. I mean, the executive would first determine if the remaining suffix made sense.
If the remaining suffix still made sense and had any chance, because it might be that the next action is still
So
executable,
that's-
right? But the rest of the plan is going to
So
fail.
that is actually how robust replanning could work, right? In the sense
Yeah,
that if you want, you basically don't want the guy who came up with the original plan to be disturbed. If there is a way of still kind of putting a stopgap support for a failing precondition, and then the rest of the plan remains, then, so.
Yeah, in fact,
It wasn't that sophisticated in this case. It was simply trying to avoid the case where you came back and the next action was still executable. Okay, but the rest of the plan was going to fail.
Yeah,
You can
yeah.
see that
Right.
because some causal link that you needed that
Yeah.
was
Has been-
not provided.
Right, in that
That
state.
makes sense. Right.
Yeah.
I don't know what you'd call that executive, but
Yeah, in fact, I think SAPA replan also has an executive that's similar to this, in the sense that it will still take the outstanding objectives and analyze if they can still be supported. I don't think it does the extended causal reasoning further down, but that's something that can be added.
So you mean for the robot debate that you are
Yeah,
working
for
on?
the SAPA
there's
replan.
an-
Yeah, there is an executive, monitoring
but working
executive.
independently from SAPA replan.
From the planner, yeah, working independently from the planner. So basically, the executive decides if the planner must be called again.
Yeah, because you keep mentioning SAPA replan, so I thought that.
Yeah,
it's,
It determines if the SAPA has to be called again.
Right.
So.
Okay, unless there are any additional public questions from any of you, we would conclude the public session, and then you get to leave. And let's thank the speaker again once more.
Take a chair back.